Okay. Then if you define a function, for example, this function here, it will plot it here. And the red curve here is the graph of this function, f of x. Okay? And you can create a table, then insert value here, for example, 2. And the function value here, you may define it f of x2. It will show you the result of the numbers you want to see. And as you can see, there are some dots here that is flat here. Okay, very nice tool. Then, or you can define the points. I'm not a master of this, but this is how I do it. I make a table, and this is the letter L, which is a random variable. I pick it here, and I choose from the starting point and the start point step size 0.1, which allowed me to change the value of L. And as you can see, this is the dot of that point x1 and f of x1. Okay, the point on this curve, when I change the number L here, the point will move, right? And go back to the example yesterday. And here, we are talking about the limit of this function when x approaches 1. Okay? And remember, this function, what is the value of this function at 1? Good job, it's undefined. Because when we plug in 1 to this function, it will be a number divided by 0 that is undefined. We don't know what it is, it's not defined. Then, but in the graph, there should have a hole right here at this point. However, the decimals is not that smart. Okay? That is why we still see it connected, but it actually should have a hole right here at this point when x is equal to 1. Okay? But anyway, ignores that. But now when we see that, if the point, the value here, which is the value of x, right, in the x coordinate, we pick it 1.4. Let us try if it approach 1, right? It reduced to 1.3, and look at the point, how it moves, right? Okay. Okay, at 1, it is not defined, so you don't see it here, right? But suppose if the value runs from 0 to 1, you see that the point is approaching to that missing point, right? And when x approaches 1 from the left, it means that it goes from smaller than 1 to 1. The point here will go down from this top to down to 0.5, right? Do you see it? Good. That is the meaning of limit. Okay, that's it. So I hope it will help you. And let us go back to the example yesterday. So we see that when x comes closer to 1, according to the table we made here, we guess that the limit of this will approach to 0.5, right? Okay. That is the lessons yesterday. Now let us continue. And here, this is the correct graph of this one. You see that there's a hole right here. See it? This is the correct one. Okay. Hello. Then, sorry. Somehow. Okay, now let us define a function g such that there are 2 branches. The first one, when x is different from 1, it will follow this formula, x minus 1, x squared minus 1. And at x is equal to 1, let us define it as 2. Then we plot this. Okay. Then on the graph here, this is 1/2, this is suppose this is 1, then 2 will be somewhere here, right? And where is the point now when x is equal to 1, y is equal to 2? Just follow the x coordinate is 1, therefore the value of that should be 1. In the vertical line here, it should be somewhere. And the y coordinate, we define it here is 2. Then from the y-axis, find the value 2, and in the horizontal line, it should be the intersection between these two imagination line should be this point, right? And here is the point, let us call it P, at x is equal to 1, 2, right? And here, this red line here, the solid line, belong to the graph, the g function. Okay. Okay. We see that. Okay, let us move on to the next concept. Let's play with another example. Now, suppose we are given a formula. Another example. We are given estimate the value of the limit when t approaches 0 of the function square root of t squared plus 9 subtract 3 divided by t squared. Okay. Hi, Monica. Now, we don't know how to compute it yet, but let us try with a calculator. Now, let us find the value when t, let us call this function square root of t squared plus 9 here, minus 3, call it the f function, t squared. Now, we use the variable t here, then the function should be the function of t. Let us define this way. Then, if t is equal to 1, what is f of 1? Oh, try it. It will be 1 squared plus what? Very good. And so use your calculator and give me a solution, an answer. Thank you. 0.162. Okay. But let us get some more decimal places. 2 and what? Very good. 7/6, right? Actually, it's just leave it this way. And 7/6 here, if we round up to 6 decimal, the number 6 is larger than 5, Then we round up to, it should be 0.6162277, and just round up to this one. Okay? Yeah, if we do. I don't remember exactly. I don't know which is a correct number here.
Yes.
Then very good. Interesting. One more decimal. Is it 6 here?
Yeah. Yes.
Oh, interesting. Okay. Then it should be 8 here, right? If we keep this. Okay. That is when t is equal to 1. How about t is -1? If t is -1,
Get the same answer.
very good. It doesn't change. Why? Very good. Because it's square, right? Right here. Then anyway, it will be 1 negative or plus 1 square will be the same 1 square. How about t is 1/2? Try it, try it. I hear some result so fast. What was it?
573.
1. Oh, 1 5? I think so, yeah. 1 6 and what is next? 5 5 2. Very good. Thank you. Do you have the same result? How about people on Zoom? Are we good? Do you have any different result? Okay. Then look at this. We're trying to compute the limit when t approaches 0. It means that we need to find the value when t is very close to 0, right? So let us find out if t is 0.01. What is it? Sorry? This is who, oh, thank you. Thank you, good job. Sometimes I think one way and write another way. Correct me if I got these mistakes. Okay, and what is it? What did you get? So very good. Correct answer. So we guess that the limit of this guy will be 0.1666, right? If we pick a smaller number closer to 0, yeah, it should be like this, or it is also 1/6. Okay. This is what we found, right? We guess, evaluate this. And let's try if decimals can help. Okay. Oh, yeah. Thank you. -3. Wow. Look at this. Very interesting, right? If we come closer and closer, oh, it's hard to see, right? But if we zoom it out, it's almost like a linear line, right? It does change a little bit. Then if we zoom it in here, it's about 1.6, like we guess. But it's anyway, just want to show you something to play at home without decimals. Okay. Thank you, Emma. Okay, this is the example. Then now we will study another concept, the one-side limit. The definition is this. Suppose we have the function named h, defined by this. If t is smaller than 0, strictly smaller than 0 here, it should be 0. And if t is larger or equal to 0, then it becomes 1. Okay? Then before we do that, let us plot this function and see. Okay? According to the definition here, let us try to plot it. Then we grab it here. Let me know how it looks like. This is the function of t, and let us just call it the axis t, and here h of t, right? And if this is -1, and here 1, 2, etc., 3, -2. And suppose this is in this axis, we call it 1 right here, 2, be right here. -1. So in one axis, the unit should be equidistant from 0 to 1, and from 1 to 2 should be the same distance. The same things in y, we can choose different scale. Okay, it should be 4 units here, and this is 1, and here. But from 0 to 1 should be the same as from 1 to 2. Okay. So from this definition, if t is strictly than 0, then the y coordinate will be 0. Where is it? Where is 0 in the y coordinate? It should be from here, right? Do you agree? And at t is positive, it means on the right side of 0 in the x-axis, on the t-axis here, the value in the y coordinate will be 1. So where is it? Should be right here, like this, right? Is it enough? Very good. Thank you very much. Here, it is strictly smaller than 0. It means that at 0 from the left, then strictly here, it means that there should have a hole, small hole here in this range, okay? And here is larger or equal. It means that at the value t is equal to 0, it takes this value, it is 1. Therefore, this right here should be a solid dot. Okay. Okay. Good job. This is the Heaviside function. And the new concept. The definition of this is if the limit from t going to 0 minus. Minus means that smaller than that value. 0 minus is going from the left. Okay? It's easy. And if t's go from the left, and f of t will always be on this line, right? And in this case, specific case, what is the value of? So let us read the definition out here. And the value of the function h of t when t is smaller than 0, it is 0 here, right? We call it one side limit. We just take the limit from one side, left or right. The negative, it means left. Positive side, it means from the right. Similarly, when t approach 0 from the right side, it means t goes from the right here, then ht will take values from this function range, right? And the value of that is 1. Therefore, the limit of this function when t goes from the right side of 0, it will be 1. That is simply this, okay? Is it clear? Okay, that is one side limit. So the definition is this. The left-hand limit of fx is h approaches a, or we say that the limit of the fx is h approaches a from the left. Two ways to say it. Is equal to the value L. L is any number we talk just depending on the function, right? And A is the given constant. Just imply that we're going from the left side of A. And this is the definition of the one-side limits. Okay. Similarly, if this is negative, A negative, right? Similarly, if the limit when x approaches A from the right side, or x goes to A plus here, then this is the right side limit, right-hand limit of the function f of x is x approaches A. That's it. Another graph to visualize the two definitions. Here, if the red curve here is the curve fx, and the point A is right here at this point, right here, right? X is equal to A, and the value of f of A will be L, for example, in this case. Then in the y-axis, L should be at this position. Okay, it's on the curve here. Project to the y-axis. This should be L because it's defined this like this. So this x goes from the left side of A, then f of x will go from this point to this in this direction. Okay, go like this. That's it. And similarly, if x goes from the right side of A, then f of x will follow this path and approach this value right here. Okay. And this is a very important point. If the left-hand limit of the function fx at a exists and it is equal to L, and the right-hand limit is also L, then we simply say it, the limit of x of the function fx is x approaches a is equal to L. If and only if. So if the left-hand limit and the right-hand limit are different, then we cannot write like this. Okay? Just accept that, just definition. Now, let us take a look at this example. Suppose we are given the graph of the g of x here. Can you see it clearly? Better now? Again, what is, okay, now answer this question. The question A, what is the limit when of g of x when x approaches a from the left? Very good. Here, right? This is number 2, and here f of 2 is, yeah, the limit. We can see this here. It is 3. Very good. Do you all see it? Good. Keep on zoom. How about the limit, the right-hand limit of the function g? Right side of this, right? 1. Very good. Any question? Yes. So now, since x approaches the right side of 2, it means that x is going this way, right? And this curve, the blue curve, is the curves of g of x here. Then what we do is we imagine. So now let's find the value of g at the point here. Draw a vertical line wherever it cut the curve here. We got this position, right? And then project that. It means draw a horizontal line wherever it cut the y-axis. That is the value of the function. So now look at here. Imagine if it's not a vertical line right here, but somehow imagine at 2, right? Imagine this is a vertical line. It cut the graph somewhere right here, and from this point we project to the y-axis or draw a horizontal line. Wherever it cut the y-axis, this is the value we're looking for. And here 2, and we see that we project it here. It has this value, right? C. Where's C? Oh, the next question. Oh, your question C. I'm sorry. We will not get there yet. But the left-hand limit is 3 and the right-hand limit is 1. Is that okay? Good job. Go back to the definition. Here, the limit in general here, if and only if, it means that if both hand limit and right hand limit give us the same value. But in this case, is it the case? No. Then we cannot write this. It does not exist. You can write D and E does not exist. Okay? Just definition. I know it's hard, new concept. You just try to get used to it. Very good. Is it clear now? Good job. And one more extra question. What is G of 2? What is it? Good point. It does not exist because at 2, it means that we should draw a vertical line going through the point x is equal to 2. Wherever it cut the curve, it should be the value of the function. But here, at 2, there's a hole here on the left branch. There's another hole in the right branch. So it means that it's not defined at 2 here. Very good, thank you. What is your name? Elijah. Thank you, Elijah. Is it clear for everyone? Good. How about, yes? Oh, 2 and 2 plus. 2 plus, this means that it's go from the right side of 2. 2 minus x approaches 2 from the left side. That is the only meaning. Yeah. Any other question? How about G here? What is the limit when G? Yes. Perfect. And here? Also 2. The left hand limit is equal to the right hand limit. Oh. Then the limit of this when x approaches 5 is 2. Good job. Yes. Good question. We're not there yet. Good point. So the dot implies that this point belongs to the graph of G. Okay? It means that G at 5 is equal to 1. Great. Okay. And 2, because there's a hole right here. It's not a solid. You see it better? Yeah, it is a hole. There's a hole here. But if it is a solid point, then that should belong to the curve. Okay. Take your time to look at that. Make sure that you remember all this. Any question? Yes. Sorry? G of 2 does not. It's not defined. Or we say that undefined. Okay. Yes. Yes. And it is very interesting that the limit when g of x, when x approaches 5 here, is equal to 2. However, the value at 2, g of 5 is equal to 1. Okay. It may be somehow undefined at this point, or it could be a different value. Okay. The limit is different things. Are we good now? Good job. It seems that everything is okay. Now another concept. Somehow the number L, the limit of the function, becomes very big. And it's very big, we're lazy, we call it infinity. And as mathematician, we're lazy, it is very big, we say that, okay, we define it this way. This is infinity, positive infinity. It means it's very big numbers. And we don't know exactly what it is, but it's very big. And negative infinity is a very big number, but very big, but I mean very negative number. Okay? It could be negative 10 billion or even smaller than that. In that case, we call it the infinite limit. Okay? But the idea is the same. For example, look at this graph. Suppose at x is equal to a, then this is the graph of the function x is equal to a. It means it is a vertical line. Any point belong to this line, take the value of x is a, right? The value in the y coordinate could be anything. If this point right here, then the value in the y could be, suppose this is 1, right? Then the point a, 1 belong to this graph, x is equal to a. We don't care about the y. Anyway, so now the same idea. Suppose the function f of x is the blue line here, and we see that it is going up, and imagine it comes close, but it becomes very big. The graph cannot show more, but if imagine it will go up forever. And when x approaches a from the left-hand side, right, then f of x, for example, this line, suppose this value right here is 1, then it cut the graph at this point, right? We project it, draw a horizontal line going through this point and cut the y-axis wherever it is. We don't care about the value. We know that this is f of 1, should be this value, okay? Be any number, it's not defined clearly here, but we know this is here. And if x approaches a, then the graph will follow this path, right? It increases to a very big number, this direction. So we say that, okay, the limit of this function f when x comes to a from the left, is infinity. And similarly, if x approaches a from the right, we see that it's also going to infinity. So in general, we say that limit of f of x when x approaches a is infinity. Just a new concept. Okay. Similarly, it becomes very negative in the below 0 here. Then we call it the limit. Here goes to negative infinity. This infinite limits. And there are some more definition here. Yeah, we will do some example tomorrow, but now we go through it together. So if a function is defined both sides, right? I think I can leave it here for you. Go home and read it again. Make sure that you understand it, and tomorrow we'll do an example. Okay, you have a good one. Thank you.